Welcome to this session on the introduction to scripting your WebGIS with the ArcGIS Python API. My name is Rohit Singh. I'm the lead developer of the ArcGIS Python API. And we have Atma. He's the lead product engineer of the Python API. And we are very excited to be here and tell you all about it. So what is the Python API? What is this? Very simply, it's the Python API to your Web GIS. Your Web GIS could be ArcGIS Online. It could be an org account in ArcGIS Online, or it could be on your on-premises ArcGIS Enterprise. Could be a portal in on-premises. It could be in the cloud, ArcGIS Enterprise in the cloud. It's powerful, modern, and easy to use. What do I mean by that? It's powerful because it has all the capabilities of your Web GIS, and that includes the ability to work with users, groups, and content in your Web GIS, all the analytical capabilities, the tools, geoprocessing, geocoding. It's all available through this API. It's modern. It's a new API that we just released, and it uses Python 3.5 or 3.6. And it works very well with the contemporary packages and libraries in the Python ecosystem. It works very well with Jupyter Notebook. And it's distributed using Conda, which is a package and environment manager for Python. And it's easy to use. So we went through great pain to make it easy for you to use it. And I hope that shows through when you start using it. And it's implemented on top of the REST API provided by your ArcGIS Enterprise or ArcGIS Online. And that's only an implementation detail. You don't need to know anything about REST, like how to get and post works, how do you talk to this server or portal. It all happens behind the scenes, but just so you understand where the API sits in an architecture diagram, this is a detail to know for that purpose. So what can it do for you? Who does it help? And let's start with, there are several user personas that this API could be of great use to. And the first one is, if you're an administrator or a DevOps person, you want to like in the plenary yesterday, I showed how you can populate a portal with users, groups, and content. You want to manage roles in your organization. It lets you do that. You want to clone a portal from production to environment. It lets you do things like that. If you're a content publisher or you want to keep updating your content in your WebGIS, it'll help you. If you're an analyst, you want to call spatial analysis tools, or you want to call the imagery, geocoding, geoprocessing, geometry, or the new, the big data analytics, the GeoAnalytics or Raster Analytics tools. If you're a data scientist, you can do all of that with this API. And if you're a power user or a developer, it's a great first API. You may not be a programmer. Python is a great language for start programming and starting scripting. You want to automate some of your processes, and this API will help you do that. And conversely, you might be a Python programmer and you may not know a lot about GIS. This could be your first use of GIS. You could understand what a GIS through this API. So it's best seen through a demo. So let me give you a quick start demo. And I'm using Jupyter Notebook. What happened? Okay, good. So using this is a browser-based Python console where I can type in my code which is executed on a Python process. In this case, the Python process is running on my desktop in here, and it's shown within the browser. So let me maximize it. And the way you start using this API is by creating a GIS object. The GIS object represents your Web GIS, and you can pass in a URL and your login credentials. If you don't pass in a URL, you are using the default GIS, which is ArcGIS Online. And if you pass in a URL, it could be a URL to your ArcGIS Online org account or to your portal. And if you don't pass in username and password, you could be using an anonymous account. So your WebGIS also has anonymous access. So you could still use this API even though you may not have an ArcGIS Online account. You could use it for several things. This API lets you work with different authentication schemes. So if you're using integrated Windows authentication, then you don't need to pass in your login credentials. It'll pick it from the running process. So this object is the entry point into your GIS. It lets you manage users, groups, and content, and it also has a map widget. So let's bring in a map of Palm Springs and assign it to a variable, and then I can query that variable. And the first time it takes a little while when it's fetching it's built on top of the JavaScript API, this widget. It's a widget for the Jupyter Notebook and allows you to embed maps within the notebook. Okay, so our map of Palm Springs showed up. We can search for content in our GIS, and let's do that by saying gis.content.search. And I could search for Palm Springs as hiking trails. And I could specify the type of content I want. I want feature layers. And it returns the results in the form for item and items. I'm displaying those items. And the results are in a form that's similar to the search results from ArcGIS Online. So I got back my feature layers about hiking trails. And I can add these to my map. I'm adding a layer. Let's add the first result that got returned. And that should update my map with those hiking trails. So you see the features are streaming in and the layer got added. So I think now we are going to start with Atma, who's going to take over and show you how it works for a few different scenarios. And you could take over. You need to switch over to your screen.
Thanks, Rohit.
Sure.
Can you guys hear me okay? I didn't get a chance to check. Awesome. So in the previous slides, you saw Rohit talk about how the API serves a variety of different users. So let's take a little bit deeper look at what it can do for each of those categories of users. In your Web GIS, in your organization, you have, on one spectrum of users, you have the GIS admins. These guys do a lot of work. They take a freshly installed portal. Maybe they ran using a chef script like how Rohit showed in the plenary session. And they populate that with users, all the users in your organization, and they create groups so these users can collaborate and share their data. And every time a user leaves a group or an organization, they have to go and clean up. They got to find what items and content the user has, and they have to decide whether they want to get rid of those items or reassign to someone else. So a lot of their workflows, a lot of repetition here, and these workflows can be scripted using the ArcGIS Python API's GIS module. And they can execute them maybe on an event-driven fashion, or they can have it in a batch file, which calls a Python script. So every time a user leaves an organization, go fire up the script. It's going to search for all the user's content and decide what to do about it, and finally delete that user. And then in the middle, you got content publishers. So when the administrators, sometimes they have to maintain two different set of portals, one on in-house development, the other one that's outside the firewall that all the other users are going to make use of. So these content publishers have to make sure that the layers and web layers are in sync between these two layers, these two set of environments. And whenever they are not, they have to run periodic publishing jobs to make their content up to date. They have tile layers, And whenever the data changes, they got to recreate the tiles in those layers. And again, once again, there is a lot of repetition over here. So content publishers can also make use of the Python API to publish new layers, to delete layers, to update the content in those layers. And sometimes when a user goes and an admin goes and deletes some of these users and their content is gone, some other end user comes and says, hey, my web map is broken. I can no longer see that layer I was able to see yesterday. So publishers have to go and mine through all these web maps and web scenes, go and investigate what all layers are there in each of them, and find out which server it points to. That server is pinging back or not, and then if it is not, they have to point to another server or stand up another server, replicate all the content in that new server. This is a day-to-day problem that these content publishers are facing, and they can use the Python API to automate a lot of these workflows. The other end of your spectrum, you have these data scientists and analysts. They mine the data set, they try to figure out all the hidden stories that the data can tell. Scientists in all disciplines love Jupyter Notebooks. You go out there, you go to sites like Kaggle and GitHub, you see various varieties of disciplines can make use of Python for the data analysis. Python is a rich ecosystem with so many data analysis packages like Pandas, SciPy, NumPy, Matplotlib library, and so on. And Jupyter Notebooks integrate so well with those things. And as part of the ArcGIS Python API offering, we have visualization, map widgets, and scene widgets that people can embed in their notebooks. And the beauty about these Jupyter Notebooks is that scientists can add narratives, pictures, and they can have GIS connections, they can have GIS data layers, they can call big data analysis tools, spatial analysis tools, and they can have map widgets that are visualizing the end result. So you have documented and repeatable research. All that the scientist has to do is to share the notebook to someone else. The other person can read the methodology and the reasons for using those tasks. And if they want to recreate and rerun the same analysis on their environment, all that they have to do is to run that notebook. So in this way, a lot of varieties of users are able to make use of the Jupyter Notebook and the ArcGIS Python API. For the next half hour, we are going to show 3 different demos for each of these personas. So let's start with this. Let's start to see how administrators can automate a set of administrative workflows using the Python API. So I'm making a connection to, I'm importing the ArcGIS library and making a connection to my ArcGIS enterprise. To get a list of all the users, all that I have to do is GIS object, my GIS connection, .users.search. If I know a particular user I'm searching for, I can specify the search parameters. If not, I just get the list of all the users. So for instance, I know my name is in there, so I can say Atma, and I can search for myself. Or if I don't know my full name for some reason, I can say AT star, and I can get my, you can use wildcards when you want to search. Let's see if Rohit is part of that GIS organization or not. Rohit is not. So let's go ahead and create Rohit as a user. To do that, all that I have to do is gisusers.create, and I can pass the username. Let's give him a really hard password that he can never remember. Give him a username, first name, last name, email address. Go ahead and run this. Look at this. I am capturing the output of this operation in a variable Rohit. So what is that variable? It's a user object. Now let's get back to this user object down the line. But before that, I also want to show you some other capabilities of the GIS module. Similar to how you search for users, you can search for content or you can search for groups just by specifying gis.group. If you're curious, I can do this. I can use the IntelliSense to find out what other properties are available on the GIS object. I can go for groups.search and get the list of my groups. Each is a group object. You can see it from here. Or if you're interested in creating a new group, you can also do the same workflow, same kind of syntax. And then if you do a shift tab in Jupyter Notebook, you get the signature of the method. You can see what all arguments you can pass. Now I know that Rohit is very interested in crime analysis and crime prediction using GIS. So I have a group here called crime analysis, but Rohit is not even a user in our organization. So we just created him. So I'm going to go add him as a member of this group. To do that, I'm going to filter crime analysis from our group and hold it in a variable called crime group. And once that's done, to add a list of users, I can call the add users method and pass a list of strings which contain the list of usernames. This is just a way of the Python API to say that you pass me a string and I did not leave any user behind. I've just added everyone. Okay. Now if we scroll back to this, in our organization we have this user. And we are not very happy with his performance, so we are going to kick him out. So to kick Batman out, I'm going to search for Batman, hold it in an object called Batman. Okay, this is not supposed to be here. And then I'm going to try and delete. Uh-oh, not so easy to remove Batman after all. So the Python API tells you that you cannot really remove Batman because that user has either items or content. So to get the content of a particular user, I can go batman.items. I want you to note something here, because when I made my connection to my GIS, I was not Batman. I just logged in with admin. But as an admin, I get the privilege to look at all users and the content for each user and the groups that each user has. So that's your power as admins. You don't need to know Batman's password or any other user's password, but you get to see that. So now let's come back and see how you can get the list of items of Batman. Okay, he got one item. He doesn't have any groups. What I can do is get the item that Batman holds, and I can say item.delete. And if you see the signature delete doesn't accept any parameters. You can just call delete and delete that item. But I just don't want to miss out on that data. I know Rohit is interested in crime fighting, so I want to reassign that content to Rohit. So what I would do is, instead of delete, I can actually call reassign to, and I can pass the target owner is Rohit. And if I even want to create a new folder for Rohit and put it inside that, I can also do that. But Batman is a busy guy. I'm told that he fights crime every night, so he may have lots of such layers. I don't want to loop through each layer. I don't want to assign it, even though that's actually easy to do. What I'm trying to say is, when you're deleting, you can actually look at the signature of this method, when user.delete, and you can directly reassign to another user. Once that runs, we can query Rohit's items. Remember, we just created Rohit, he doesn't have any other item. Okay, maybe let's run it one more time to allow it to refresh. Let's get Rohit one more time. All right.
Command worked. Can you check up, scroll up? No error there when you reassign or deleted it.
Yeah. Seems to be.
Username is okay.
Yeah.
Okay, so I guess they could come.
All right, we'll figure out that error. I swear it worked this morning. Okay, so I just wanted to show this notebook that as GIS administrators, you don't even have to log into your portal for ArcGIS or ArcGIS Online to do some of these common workflows. You can automate all of that using the Python API, and your organization has your own unique workflows of how to do this kind of operations. When someone leaves an organization, someone joins the organization. Like Rohit showed in the plenary demo, he had a CSV and he read from the CSV. Each row corresponded to a new user, and he was creating that. It doesn't have to be a CSV. It could be your Active Directory. It could be an email alias with a set of users. Python can read all of that. You can have so many libraries to do that. So you can get a set of users and create all of them in your portal or ArcGIS Online, and you can write your own administrative workflows. Now let's change gears a little bit. And the next demo we have is to show how content publishers can automate some of their workflows. California has really intense summers, and forest fires are fierce, and so many properties are lost every year during the summer months. So I am imagining a case where a publisher in a GIS group of a particular company is tasked to find out which of their assets distributed throughout Southern California is at risk every year, every summer, every day when the forest fire boundaries and perimeter changes. It's a simple GIS analysis. You get the forest fire perimeter either through authoritative source, or you take it from a satellite imagery and digitize the forest fire boundaries. Then you know the locations of all your assets. You make a buffer around your forest fires just for caution, and then you do an overlay analysis, intersect, and find out which of your properties are at risk. And then you know, okay, these properties are at risk. You take the precaution whether to evacuate them, or you set up all the precautionary scenarios to protect the property from forest fires. This kind of analysis has been going on for a really long time. So what we're trying to show here is how such scenarios can be automated using Python API, and how those scenarios can be run against your Web GIS. You can compose web maps on the fly, and you can share it out. And these kind of things can be scripted. It can be event driven. Every time a forest fire boundary changes, a forest fire layer it gets updated, program such that this analysis or notebook gets run. So let's run through this pretty quickly now. I'm connecting again to my ArcGIS Enterprise. And here I have a forest fire layer that I'm filtering and searching. Let's recreate this map widget one more time. Let's bring up the map of Southern California. I'm adding all my infrastructures to this map. You can see I have so many different points. I have so many different storage facilities, or godowns, or factory outros, factory premises, and so on. And in another layer, I have the forest fires. I apologize for choosing this bad symbology, but this green polygon is where my forest fires is. Are you able to see this polygon at all? Okay, that's good. So what I'm going to do is, from my features module, I have use proximity, and in that class I have a set of tasks, a set of methods like create buffers. I can call that, and I can, as an input, I can give my fires layer. I can set the distance, which is the amount of distance I want to run the buffer on, and I can set my units. I can give it a timestamp. I can give it a output name. Just run it like this. What I want you to take away in this step is that this buffer is not run on my local laptop. It's actually run on my enterprise. It's run as a GP task on my enterprise. So this could be a simple operation, or my layer could have hundreds of thousands of points. And your enterprise is a way powerful machine than your workstation, your local computer. And it's run on the enterprise. And once it's run, I'm trying to share it so all the other users in my organization can make use of that. So this is another kind of task that publishers always do. They want to share their items to someone else, and it's as simple as item object.share, and then you pass through, and then it gets shared to everyone else. If you want, you can look at the optional parameters. You can say everyone true, organization, you can just share it to an organization. For groups, just specify the group name. Let's add that file layer to our map widget. Look at that. I'm creating and holding the map in a variable, in an object called m, and I can call the add layer method and pass that item. And if you scroll up, this is my fire boundary, and you can see the buffers in blue. Now our next task is find out all those point layers, all those facilities that are intersecting in these buffers. And those are the facilities that are at risk at this point. To do that, in my features module, under manage data, I have overlay layers. If you want to know what is the set of all those tasks that's possible, I want you to take you to the API reference. We'll get to that in a bit, but I want you to take you to the API reference, and under the features module, you have a number of submodules like this. Analyze patterns, enrich data. If you expand this, you have those methods that you can call. So we are going to do manage data. We're going to do overlay layers. And as an input layer, I'm giving the buffer layer, and the overlay layer is my infrastructures. I'm going to run it and hold it I'm going to create a new feature layer and hold it in a variable called risk infrastructure. And once again, I can share that to everyone in my organization. Okay. Once that's done, let's look at what all layers are available in my output. I have a feature layer that corresponds to the properties that are at risk. Next, what I'm going to show you is the ability to read those feature layers and look at all the attributes. Ultimately, what I want to find is only those, out of those 60 or 70 infrastructures, I want to find only those limited structures which are at risk. And here I'm showing you how you can read that as a pandas data frame. And Jupyter Notebook has a really nice way of visualizing the data frame as a table. Like this, I can see the attribute table of the output layer. You can see it's really busy with so many different layers, so I'm going to filter that out and only show you the relevant columns. Out of those 60, 70, or 50, 60 infrastructures, only 7 of them are at risk. At this point, I can burn that into a CSV and email that out to someone or the field crew and tell them, okay, stop your work, look at these features, these are the addresses, go and secure them. And once I do that, I can proceed to create a new map. I can add those layers into the map. So these are the locations of those layers. And I can proceed to do this. I can go look for an existing web map, read that web map as a web map object. I can loop through the operational layers. This is a map I published during the previous forest fire. And now all my field fighters know this map. They already have them in their device. So what I can do is, once I read that as a web map, I can loop through the operational layers. I can find out the URL for the old service, old feature layer, and point that to the new output I just generated. And I can save. I can update the web map. I can send them off. I can tell them, okay, you remember the past web map that you used last year? Now it's updated with a new set of features. Go make use of them and do the needful and secure our properties. So in this way, I can save this notebook file download as a Python script. I can schedule that Python script to run every time a new forest fire breaks out. And I don't have to do anything. It goes, gets my old item, it updates with the new output of the analysis, and boom, my work is done. This end-to-end automation with Python API. Now I want to shift it to Rohit Singh, who is going to show you the other scenario that can be automated.
Okay, so this scenario is about an analysis, and here we are looking at a subset of observation data from hurricanes across 100 years, from the 1840s to the 1940s. And it has several 100,000 points of observation data. But looking at this data as an analyst, I want to answer a few simple questions. Did the number of hurricanes increase during that time period? Or did their intensity or the wind pressure increase or decrease during that time period? And for this analysis, I'll be using, because I have so much data, I'll be using GeoAnalytics, which lets you do big data analytics. So I'm connecting to my GIS, and I'm passing in the username and password. So your GIS needs to be licensed with GeoAnalytics, and a GeoAnalytics server needs to be there in your GIS, and I'm just verifying that it's there. So that's how you get to know. I'm getting the data stores of GeoAnalytics and searching them, and I see that the hurricanes data set has been registered as a big data file share. Now yesterday in the plenary demo, I had shown how I could have a folder with shape files or CSV files and add it as a big data file share, and then GeoAnalytics goes within that folder, discovers all the data sets, and for each data set that it finds within, it creates items in your portal. And so here I'm searching for those items. I'm searching my GIS for big data file shares related to hurricanes, and I find that. And I'm assigning this item to the hurricanes variable. I'm now ready to import. So I want to use the reconstruct tracks tool provided by GeoAnalytics. And what it does is it creates tracks from observation data. So it's going to look at all those points in the hurricanes layer and create tracks as the hurricane progressed. So in a way, it's summarizing that data from those hundreds of thousands of points. Is going to summarize it to just the hurricane tracks. So this is going out to my WebGIS and running this analysis. And it's going to be distributed across the GeoAnalytics nodes in my WebGIS. It's a distributed task. So it started the new distributed job. We started getting some output. It's an option to see this output or not see it. So in the ArcGIS.environment module, you can set the verbose output to true or false. By default, it's true, so we are seeing this output. And the way the GeoAnalytics module is written is that just like in the web front end in the home app, when you click on the analysis button and you see the tools, they are categorized by a group. Like it could be summarizing data, it could be managing data. So we follow a similar convention in the module design, and that makes it easy to transfer your skills from the web interface to the Python API. And you'll see these patterns across the API. So that's to try and make it simple for you to do it. So my analysis completed, and I got back the results in the form of this tracks variable. And I want to now add the tracks to my map to visualize it. That's the analysis results. They should be streaming in now. And we see that there are still far too many hurricanes to make sense of. But since this data is time enabled, I can set a time extent and only see the hurricanes in a particular time period. So here I'm only seeing them for a particular decade. Now it's not as if I can only visualize these results. I can use the data behind these results. And any layer in your GIS, you can do a query on that layer and get the attribute table. And I'm not specifying a where clause. You could filter it by a where clause. And I'm saying that from that resultant attribute table, treat it as a data frame, which will bring it as a pandas data frame. And I'll see I'm saying df.head to just see the first 5 rows in that data frame. So we should be seeing that soon. We got back our results, and we see that there are several 5 rows, and there are actually a lot of columns, 969 columns of data and observations and summarized statistics. I can query my data frame for its shape. So I see that there were 2,000 rows and 969 columns. So it was able to summarize those hundreds of thousands of points into into 2,000 hurricanes, and it's given me the distribution of those by the basin they are in, like the Southern Indian Ocean basin or the North Atlantic Ocean and few. So coming back to the analysis that I wanted to do, has the number of hurricanes increased over time? And here I'm using pandas, which is Python's data access and analysis library, to sort and group those and plot them as a bar chart. I can fit a trend line, and I see that in this data set, for whatever reason, the number of hurricanes is increasing during that period of time. And it might be because maybe earlier we were not collecting so many hurricane observations, but yeah, that's the analysis that the outcome of my analysis. And I could do a similar analysis like for their duration or intensity. And here I'm doing a scatter plot analysis and fitting a trend line, and I see that in this data set, the duration did not statistically increase, like it's a flat line. Now, switching gears, we also have raster analytics. We have good support for imagery layer and raster analytics in this API. Getting a little more space here. And here I'm searching my GIS for Landsat imagery and displaying it. And I'll be using this multispectral layer from the Living Atlas. And I'm creating a map here of a place in Montana and displaying that map, to which I'm adding this imagery layer. So we see the imagery layer has shown up, and there are some water bodies. Now these imagery layers have some properties. One of the properties is raster functions. These can be published with raster functions that do on-the-fly image processing at the display resolution, and they can show different raster functions such as agriculture, bathymetric, color infrared, and so on. So I just cycled through those here and graphically, visually showed you how these raster functions could be applied. Now, I can compose my own raster functions as well. I can do band arithmetic. I can combine, extract bands, do stretches. All of those are available, and this is how you can compose a raster function chain. And here it takes in as an input the bands and extracts those out, then does a stretch. So on the imagery layer, I can apply my raster function as well. So I've applied the 4-5-3 band combination to identify where the water bodies are, which show up as black here, and where land is. Now with raster analytics, we can take this processing and apply it to a raster layer in our portal across the entire extent and at source resolution to create an information product. So that information product will be similar to like a land water boundary information product that's published on ArcGIS Online, and it can be used for analysis and visualization. So this is again doing a similar process. It's going to my raster analytics servers, creating, applying that band combination and creating this imagery layer. And the band combination I applied for this analysis is the 752 band combination, and that's improves visibility of fire and burn scars. So in this case, I was actually using the imagery layer was showing a forest fire in action, and in the red and purple pixels we start seeing the burn scars and the active fires. So yeah, that concludes my demo of raster analytics and GeoAnalytics. I think now we'll go back to Atma and we'll do. Before we switch to Atma, let's see how can you get this API. And the API is distributed through Conda, which is Python's package and environment manager. So going to the slides here. And it's an easy install, and rather than showing you the slide, let me show you a quick time-lapse video of how I'll get this API. So Conda is actually a product from Continuum Analytics, which is one of our sponsors here at this Dev Summit. And you would go to Google and search for Anaconda and download the latest version of Anaconda for Python. It's available for Windows, OS X, and Linux. There's also a mini version of Anaconda called Miniconda that you could use, and we actually ship Miniconda as part of our ArcGIS Pro install, and you could use that as well. But the benefit of using this full version is that it comes with a lot of libraries that you would be using in your workflows. It comes with pandas, it comes with scikit-learn, it comes with Jupyter Notebook, which is a really good interactive IDE in your browser that we are using. So I downloaded that, and now I'm running the Anaconda installer, and it's a simple install. You just do next, 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 and install it. Now, while I was downloading it, you would have seen that it prompted me to give my username, my email address, and prompted me to download the Conda cheat sheet. And I would recommend that you download it and look at that Conda cheat sheet. It gives you, just one small PDF that gives you the most common commands that you should use to start being efficient, start using Conda. So okay, my Anaconda got installed, and now I can go to my start menu and just open my command.exe, and then I can start issuing my Conda commands. And I could also do it through the Anaconda prompt, or I could just do it through command.exe. And if you're on Linux or Mac, it would be your terminal. So the command to get the ArcGIS Python API is you say Conda install, and you specify the channel name, which is Esri, Conda install -c Esri, and you specify the package name, which is ArcGIS. That's going to fetch the ArcGIS package, and if it has any dependencies, it's also going to fetch those dependencies and install it. So I'm just following the prompts, installing it, and my package is it's got the curve. Since I'm installing it on Windows, it's also getting Kerberos, so I can use this integrated Windows authentication. And now it's installing the widget that's also built into the install. But you see those extra steps that it's doing to make sure the widget also gets hooked up with Jupyter Notebook. And my install is now complete. I can start Jupyter Notebook and start playing with the API like I had shown you earlier. So I think that concludes this installation part. And if you're using ArcGIS Pro, you could also install it using ArcGIS Pro. Pro has a Python backstage. If you click on the button on the top left, and it lets you search for and install different Conda packages. And in this case, I'm showing that I have already installed ArcGIS package. It shows up here. I could also search for those packages by using the add package and get it that way. So you can use the ArcGIS Python API in combination with ArcPy using Pro. So now let's switch to Atma, and he's going to show us some resources that are going to help you.
Thanks, Rohit. Yeah, a lot of things that we showed today are available on the product website. If you go to developers.arcgis.com/Python, you have a lot of sample notebooks, a lot of guide chapters, API reference, and everything in summary of what you want to learn. If you're taking pictures, I want to take you to the live website. Cool. So this is the product website. And if you go to the guide, you can head over to the GIS module and you can learn about how you can use the GIS module to manage your content, to look for groups, to manage users, delete users, create users, and a lot of those things. Likewise, you can take a look at each of those different modules in the Python API, such as features and working with imagery layers using the raster module and so on. Then you can take a look at sample notebooks, which are slightly different from guides because sample notebooks target an end-to-end workflow, a realistic workflow, which will make use of multiple modules, multiple different libraries other than just ArcGIS Python API. For instance, the hurricane fires, the hurricane GeoAnalytics demo that Rohit just showed can be seen from this product website. You can go through this, you can show that to some of your colleagues to show what the Python API can do, etc. Then you can take a look at the API reference. I took you to this API reference earlier when I wanted to show you about overlay analysis. This is a standard Python API reference. You can use the search and look at each of the different classes, different methods, and all the optional parameters that we are not showing you in this demo for want of time. Then we have a growing and really active GeoNet community. I think some of you here are already part of that community. I recommend you to go join this, take a look, and post your questions and answers and help other users who have other questions. At this release, during the Dev Summit, I also want to take your attention to some new advances we have in the Python API. We just started shipping the Python API as Docker containers, Docker images. So here you have in the install and setup, you have instructions for how you can get the Docker image and how you can run it on your computer. The advantage of doing this is that you don't really have to install Conda or mini Conda and set up different things. This Docker image already has Conda and already has the Python API installed as well as the samples and the SDK. So it's a one-stop installation for you if you are already using Docker extensively in your workflows. And another sweet thing we also did is this, the Try It Live link. We put this Docker on a server, so every time you want to just temporarily take a look at some of these Python notebooks, you can go to this link and spin up a new container for that instance alone and make a use of that notebook. Let me show you something before I keep rambling about this. For instance, this is a sample notebook. If you want to try it live or show it to someone, just click on the Try It Live, and then it spins up. Looks like some of you have already started using it. That's a good thing, yes. So if this worked, you would just have the Python notebook just spin up, similar to what we just saw during this demo. And it is very live. You can go feed in your credentials, you can start using it, and you can experiment with it without installing anything, not even Docker, anything. So let's get back to the slides. Yes, and that concludes our presentation. Rohit, do you want to talk about the road ahead?
Yeah, so is it up?
Yeah.
Yeah, sure. So we just released the 1.0 version in December, towards the end of December, and we just came out with an update, 1.01, that was a bug fix update. Towards the mid of the year, we are planning a release around the UC time, and one towards the end of the year. Some of the things that are coming up are the spatial data frame that I showed. That's a very powerful feature. I think it lets you treat spatial data, feature data as a pandas data frame, and just like in pandas, you can do attribute queries and joins and merges. You could do all of that using spatial operations as well. And in addition to that, you could export and import shapefiles and file geodatabases. So that gives you a way to suck in data from so many different sources and add it to your GIS. Another ability that's coming up is the server GIS, and that so you know that Python API works with your portal or ArcGIS Enterprise and Online, but what if you have servers which are not federated with the portal and you still want to administer them? So all of the server API part is also going to come into the Python API. And there are several other interesting areas that are in the works to some degree or another. I think now we could open up to questions, right?
Yeah.
Sure. You go ahead. Update topology. The symbology. You have some to update symbology on a feature layer?
Yes. So in a feature layer, you can have symbology in two different levels. One is that it could be on the feature service that you just published, or it could be on the item. And you can do both. If the layer symbology is on the feature layer, you can use a feature layer manager object, and you can do an update definition, and you can recreate the entire symbology. And if it's on the item, you can do an item.update, and in the text property of the update call, you can pass the entire JSON that you wanted to update. Yeah. Down the line, we'll make it even more easier. But right now, you will have to have knowledge of how the symbology appears, that the JSON reference you may have to have if you want to do that call.
So you had a question?
The API release for server.
Yes. That would be before the user conference, around the mid of the year. Yes, please.
A lot of the data on the web are in the WGS 84 that long formatted, but a lot of the analysis tools in ArcGIS use Canadian distance as a calculation. So if your system will provide some kind of warning to users that when buffer function may not work when you have that long and
So some of so the question was that a lot of data is in which WGS
Yeah.
84, right? And the analytical functions do not only work with Euclidean geometry, and they don't work with geodesic geometries. So the answer is that the answer that I know about is that some of the functions, like reconstruct tracks, for instance, that I showed, they do take in a parameter to specify what geometry they should work on. So in the analysis that I did, I could pass in, I did specify that it should use the geodesic geometry. So I believe that in it might be true to a greater extent in the desktop GIS, but probably in the web GIS, when we are exposing these tools, I'm assuming that we are accepting a geometry type parameter. Please.
Many utilities are still on ArcGIS 10.2x, and I was wondering what your recommendations are if we wanted to implement a Jupyter Notebook using Python 2.7. I did it, but I think I screwed up some of my environments, so I was wondering.
So Jupyter Notebook does work with Python 2.7. The ArcGIS Python API does not work with Python 2.7.
Some of it does. Got it working.
You got it working?
Yeah.
Okay, yeah, I know that some parts of it would work, some parts of it would not work, so we don't support it. As of now, we do not intend to support 2.7. Our plan is forward-looking. We want to use the new features of 3.5 and above. Like there's asynchronous processing, and there's the type hinting, which we think improves the API. So we don't want to be locked up with the old version. And since this is a new API, we just want to go with Python 3.x and above. Yes, please.
Can you install this API without Conda? Like let's say I have tested my script in Jupyter Notebook and I want to deploy that somewhere else. Maybe I just want to do some pip install. Can I do that?
We do not have a pip install yet, but that's a good feedback. Do you think that it's an impediment to install Conda? That's why you're asking? Or?
Well, some of my clients are secure environment, and secure means cumbersome to install anything I don't need. So whatever makes my life easier.
Yes.
Do you want to take an answer for that?
Yeah, sure, Atma.
Are you, for pip install, are you trying to install from a local location?
I never tried that. I'm wondering if that could be
Okay.
something that I'll just download the API, do a setup, and here I go.
Okay. There's a strong reason why we want to encourage Conda, and because Conda takes care of managing all the dependencies. Exactly.
So you would need to install tons of other stuff before getting into one, pretty much, if you don't use Conda?
You can still use Conda and do local installs. So we have a small chapter in the install and setup. If you head over here, which says about how you can set it up using for offline install cases. And we also have a KB article of how to do offline install for secure, this specifically for secure environments in mind. You can download the Python API as a tar file, and you can use Conda to do an offline install.
Okay, that's great then.
Yeah.
Thank you.
You're welcome.
Sure. Yes.
Can we use this notebook to transfer users' items
Two portals.
to like I have like production.
Yes, so let's show that sample that clones the portal. We have a sample for that. It takes you from a staging to a production portal and moves your users, groups, and content. Yeah.
Yeah.
Yes, please.
Is Conda sort of an answer to using virtual environments?
Yes, it is, and it's supposed to be a better virtual environment. So it manages it's a dependency manager, and it also is a virtual environment manager. And a lot of, Conda is now becoming like the de facto way in which packages are distributed and installed. Yeah. And it's across the ArcGIS platform, like even for Pro, Pro has adopted Conda as their distribution mechanism. And for the ArcGIS ArcPy for Linux, we started distributing it as a Conda environment, Conda package. Sorry. You had a question back there? Yes.
With the server package that you're going to deploy, are you going to have a closed capability as well so that I can move my server deployment between environments?
Yes, I think it would be there because server has an import and export API, and the REST API is already there. So I believe we will certainly expose that through this API.
In that corner, yeah.
Sure.
With the searching, you just kind of showed a very simple single term. You guys work out the searching?
Yes. So
Documented anywhere if I have.
can you bring up the search REST? So the search actually uses the search. It's the same search that's shared with ArcGIS Online, and the REST API gives the documentation, and you can use very advanced search boosting, searching by title, and our search API in our API reference, it actually points to the document that describes the search in detail. Sure.
I want to. Oh yeah.
Can you just give a preview of what you're going to be talking about in the advanced scripting session this afternoon?
Yeah. So we are going to go. That will be like we'll go into the API in the advanced section, and yeah. So at 1 o'clock in this room, we've got the advanced section, and some areas that we would be talking about are how to use the GIS module, how to use the features module, updating features, getting feature layers, updating maybe the schema of a feature layer, how to use the raster module, how to use geoprocessing, and I believe geocoding is also there.
Yeah, a little bit of geocoding.
Little bit of geocoding. So we'll be getting into those modules in the advanced section. Yeah. All right. Thank you, everyone. Sorry, you had. Okay, maybe we'll take it offline. And thanks a lot.